right, so we are moving on to arithmetic sequences. So here's the general idea of what I wanted you to take away from our previous unit or our previous lesson. Our previous lesson was I just wanted you to see patterns and numbers and patterns, and I wanted you to be able to recognize that you could be given a list of numbers or you could be given a definition of a list of numbers. That's like your explicit formula or your recursive formula. That would be a definition of a pattern. And then you can use that in order to create your own list of numbers. There was a section in your homework, 2, E, F, G, and H on your daily agenda. I've already addressed these guys, but let me real quickly, in case you didn't see it on your daily agenda or just kind of breezed over it, tell you what's going on. So when I got to those points in the homework, when I was making the answer key, I was like, that's kind of unfair that you were given a recursive formula and then you're still being asked to find the 50th term. And I was like, well, are they going to have to then just kind of figure out how to turn this into an explicit formula, which you can do. And I was like, but they don't know how to do that yet. So I was really concerned that I had given that to you as a homework. And then I looked at the answer key, and the answer key was like, make sure you're using the sequences form or app on your calculator, and both TI-84 and TI-Nspire have a sequences system or app that you can use on your calculator. So you can use a recursive formula and then use your calculator, and your calculator will generate all of the numbers. So the infinite numbers that are in this list of numbers or in this sequence. So make sure I've posted videos for a TI-84 versus a TI-Nspire. So 2 different videos on how to use that in your calculator to solve for E, F, G, and H. I would highly recommend that you take this sometime today or with your next homework to play around with it and get used to it, because it is a really helpful tool if you ever need to do the 50th term of a recursive sequence. Okay, so we are moving on to 6.3, which is our arithmetic sequences. Arithmetic sequences are repeated addition. So thinking back to your homework or to our last notes, there was tons of patterns. But one of the patterns that you saw was this idea of just adding the same number or subtracting the same number a bunch of times. So examples of arithmetic sequences would be like 7, 14, 21, sorry, it's my bell schedule, and that's somebody trying to get a hold of me, 28. So that would be an example of an arithmetic sequence here. Your first term, your A sub 1 or X sub 1 or U sub 1, whatever that first term, however we choose to define it, is 7. Your common difference is also 7. Common difference is the phrase that we use to talk about the number that you're adding or subtracting every single time. So here, A sub 1 equals 7. D for common difference is also 7 for 2 different reasons, right? 7 is just the first term that's there, and then we're adding 7 every time, so 2 different versions of 7. A different arithmetic sequence would be 2, 11, 20, 29, 38. Our first term, A sub 1 here, actually, let's just change up the variable. I'll call it B sub 1 because I want to make sure that you guys realize that it could even be Greek letters in there. Any letters that you choose to put in there, it's just how you've chosen to define it. And B sub 1 is going to be different than A sub 1, which means we're talking about 2 different sequences. The changing of the variable means you're talking about a different sequence. So here B sub 1 is 2. Our D, our common difference, is 9. We're adding 9 every single time. Our third and final example, let's actually keep going with the Roy G. Biv, we'll do 48, 39, 30, 21. Our first term is 48. Our common difference, we are subtracting 9 every single time. So since we're subtracting 9, this guy is going to be negative 9. Now, it's easy to point those out, or relatively easy to point those out and be able to determine them when you're given a list of numbers, but it's not going to be that easy for the most part. I was like, it's not always going to be that easy. It's mostly not going to be that easy. We need to have a formula in order to be able to take these guys and turn them into their own explicit formula. So I'm going to show you how we derived this formula. Heads up, pro tip. This formula is in your formula packet. It's on like the very first page of non-prior knowledge. You have like a page of prior knowledge information, and then you have the very first page, very top one, because this is something that a lot of teachers tend to teach this at the very beginning of the year, but we're doing it at the end of the year. I think it's nice to do something easy at the end of the year. Okay, so let's talk about the formula for how to make a formula for these guys. So when we're trying to make the formula, we have, we follow this pattern of the repeated addition. So if we were to talk about the first term, u sub 1, it's just u sub 1. But if we start talking about u sub 2, we know that it's your previous term plus that common difference, that number that keeps getting added every single time. Okay, so continuing that pattern, going to u sub 3, well, that's your u sub 2 plus the common difference. But we already have a definition for u sub 2. U sub 2 is u sub 1 plus d. So if it's u sub 2 plus d, it's u sub 1 plus d plus d, right? So if this guy is your u sub 2, now you're just combining like terms. So that'll become u sub 1 plus 2d. Okay, so then u sub 4 is going to be u sub 3 plus d. U sub 3 is u sub 1 plus 2d. So then adding on another d would be u sub 1 plus 3d. So now, as we're continuing this pattern, we're starting to recognize things that are going to stay the same. We can always boil it down to u sub 1 at the beginning, so our first term at the beginning, and then notice the relationship of your n term. So this is an n of 4, and then the number in front of your common difference is 1 less than that. And that pattern will hold true for the next one as well. U sub 5 will be u sub 1 plus not 3d, but now 4d. U sub 6 is going to be u sub 1 plus 5d. And that is where your formula comes from. At the very top of your page, of your like first or second page of your formula packet. So the final formula is u sub n equals u sub 1 plus n minus 1 times d. And that's how you make your equation. And you can find this in your formula packet. So if you want to write a little note to yourself and say it's in the formula packet, you can even write down what page. It's a total strategy for going into the IB test is to know your formula packet like the back of your hand. It should be a pretty familiar thing. Okay, it's always exciting zooming back out. You're like, oh, I was writing so tiny. Okay, so we're going to find the nth and the 50th term of the sequence. And so it gives us a sequence, a list of numbers, and then we have to go from that forward. Finding the nth term just means to find the formula. When it asks you to define a sequence, find the nth term, or find the explicit formula, it's asking you to find the formula that defines this. So we know it's an arithmetic sequence, so you should first, once we start to learn all the different types of sequences or the other sequence, we need to first look at the pattern and recognize the pattern. We go from 2 to 11 to 20 to 29 to 38 to 47. We are adding 9 every single time. Repeated addition is going to be an arithmetic sequence. So we can write down our arithmetic formula at the very beginning. U sub n equals U sub 1 plus n minus 1 times d. Well, U sub 1 is 2 and d is 9. So putting that all together, we have that U sub n equals 2 plus n minus 1 times 9. Now you could distribute the 9 both to the n and to the negative 1. So like sometimes you'll see your explicit formula where it doesn't have it look like this, and it just means that they expanded the expressions. They did 9n minus 9 and then combined it with plus 2 to be 9n minus 7. So it doesn't look quite like this, but it is still the same formula. I would leave it like this just because I think it's easier. We don't need to do extra work if we don't need to. Okay, and then we want to use that to find the 50th term. This would be a key example of where follow-through points would work, right? The first question of an IB question would be like, hey, find the nth term of this sequence. And then part B of that question is, okay, find the 50th term of that sequence. If the equation that you got above is wrong, but you use it correctly in the next part below, you get all of the points, even though the numbers could be totally wrong. Not all the points. You get all the points for part B, but not for part A. But it's still more points than you would have gotten before. So remember, follow through points. U sub 50 is going to be equal to 2 plus 49 times 9. So U sub 50 is 443. Okay. That's it. That's about as easy as we're going to get. So we're just using the formula that we have in our formula packet, defining the first term and the common difference in order to make our equation, and then using our equation to find a later term.